Well, I'm going to talk about steep slopes, odors, and corrosion flowing together. It's kind of a more practical application of a condition, and it won't. Historical perspectives, we're talking about sewers here, and we're talking about physical aspects of sewer operations and sewer collection. In the past, collection systems have really been identified as out of sight and out of mind, and not really had great understanding of what's happening underneath. It's an underground system, and so it is largely unknown. And so the design intent in doing sewer systems is essentially to try to transport your community wastewater to the plant, to a system, to a wastewater treatment plant where it can be managed. But we really don't have a very good understanding, haven't had in the past, very good understanding of what was going on within the system, whether or not it was corrosive or not, or how things were actually being managed. And so there's essentially an underground menace, a trouble underground. Next slide, please. And so the reality really set in as a result of not understanding what was going on until we got to a point where we started looking at our assets, and folks started doing asset management and started inspecting some of what we have, not only from a plant perspective, but also asset management of sewer systems. And we discovered that there was a lot of odor formation and corrosion that was going on within the sewer systems, and that the impacts of some of our designs of the sewers were really creating a negative impact, not only from an odor point of view with community complaints, but also from a system corrosion and infrastructure being compromised. Next slide, please. And so the solutions that we've come up with, once we really got to understand what was going on, was to figure out, I try to identify what the hotspots were, how to protect some of those surfaces from the corrosion that was being formed. And in order to do that and try to minimize the odor impacts, we started adding chemical, and we're extracting and treating some of the systems. We're just letting it vent out to get it out of the system itself. So all these steps were designed to mitigate both the odors and the corrosion aspects of what was happening. Next. And historically, sewer designs were really only worried about connecting A with B, your sewer house and toilet with the collection system and the treatment plant where it was going to. And I don't think in the past, it didn't seem as if the engineers really developed or anticipated what some of the impacts of some of their designs were actually going to import. And so those physical layouts that they made or they provided were actually providing some impacts that were probably unintended. Next slide, please. So moving forward, what my proposal is, conclusion of this is that working with people who do those designs, it's enhancing their understanding of what actually goes on within the system so that we can consider different materials of construction to protect the surfaces, understanding the odor formation and release so that we know what goes on and how to design around it, so we can reduce turbulence that would cause some of that stripping, and then build in better control systems. These are some of the things as we do moving forward. However, I wanted to take a look at what I'm talking about when I mention that certain physical layouts have implications from an odor and a corrosion point of view. One of those conditions in my condition statement is essentially where we have a steep slope that combines or meets up with a flat slope. And one of the common locations is when we have a force main. Of course, the force main's built and designed to pick up a wastewater flow from a low point, bring it to a high point. And so we're always going to be at a high point with that force main. And then it's going to slope down generally to meets another intercept or another line. And that slope is generally a little bit more steep than what it connects with. And so we have to understand what those conditions that are going to occur when that steep slope meets the flat slope. That's part of our design. Next slide. So as we look at the high velocities of the steep slope coming down, air and water is moving rather rapidly, and it meets the lower velocity, which is slow, and it kind of hits a dam. You have the turbulence or hydraulic jump where the two of the slopes meet based on the velocity change from the high to the low velocities. And that hydraulic jump, not only do we have the turbulence that's created, we have a stripping that occurs, and we also have a pressure plume. So next slide, please. So the result is, as I mentioned, the turbulence, which is the stripping that occurs, the possible air pressure envelope that moves not only downstream, but also moves upstream along with it. And so the result of this force main steep slope needing flat slope creates an environment that is conducive to corrosion and stripping of odors and odor implications both up and downstream of the actual meeting point, the intersection. So I present two case studies here, both from Northern Kentucky, and let's get into them. The first one that I'm going to talk about is a pump station breaking to gravity. It's a force main, 3 mile long, breaks to gravity at the top of a ravine, connects with an interceptor that's at the bottom of the ravine. The particulars, it's a rather steep slope, and shortly before the interceptor meets, there is, or I should say where the two of them meet, was a T intersection to begin with. I'll give you some particulars on the next slide of what that piece was. Next slide. So the stats were, it's about, the force main was about 3 miles long. The diameter was about 30 inches. We had about 8 mgd worth of flow. And the slope down from the break from force main to gravity was about 20%, rather steep slope. And when the two of them meet, combine at a T intersection, you can imagine the amount of turbulence that was created and the pressure plume that was created at that particular point. And so we had a big problem, not only with odors around the ravine, but the laterals that connected to that interceptor that was in the flat slope area down in the bottom of the ravine, and which radiated back up into a new set of condominium homes that were a little bit higher end on the economic spectrum. And so there was a lot of complaints. Next slide, please. So what were our solutions for this problem? Well, first off, to try and minimize the amount of turbulence created by the combination of the steep slope and the flat slope, we connected with a Y instead of a T, try to minimize some of that turbulence, make it a smoother transition. And that worked for a little bit, but still you're going to have from the steep slope of 20%, going to have that stripping action that occurred. And the initial plan was to extract the odor from that location in the headspace and treat it in a biofilter that was going to cost in the tunes of $1 to $2 million based on the flows. However, in talking further with the client, another option was available, and that was there were between where the two met in the ravine and toward the plant, there was about a mile worth of marshland that allowed us to consider just letting the odor travel down through the interceptor into the area where there was no public, and discharging it there, so minimizing and allowing them not to have to worry about the odor control. In addition to that, we put traps on the connections, the lateral connections to that interceptor, so no odors could travel up the laterals to get to the home. So what started out as a rather potentially expensive solution turned into a simple one as we started to examine where and how we might actually address this odor in a more simplistic manner. Next, second case history had to deal with another Northern Kentucky force main break to gravity. That was, again, another steep slope that traveled for quite a distance on the slope. But there were a lot of odor complaints around the steep nature of the slope, not even at the bottom before it even got to the base. Next slide, please. And so we did a lot of examination of to better understand what was happening with this force main and steep slope area. As you can see in the graph to the right, they had several different steep slope areas associated with this. And I'm going to talk about the top end of this. And a section of the gravity steep slope area that was connected with homes. And if we can go to the next slide, please.
Hey, Dick, I know you got a little delayed, but you could pick it up?
Okay.
Yeah, we have like 3 minutes for the next until the next speaker. So,
okay. So to make a long story short, what ended up happening was when the pumps are on and the house connections that were connected to that steep slope, when the pumps were on, there was a lot of before the wastewater met the steep slope, the pressure forced odors into the homes that were nearby. Not meaning to, but as soon as the water got there, then the negative pulled air out of the homes. So there was a interesting dynamic that occurred when the pumps were on and pumps were off, causing pressures on and off. And so the solutions to this system, next slide, was simply to make sure the traps were working, but really, go to the next slide as well, really to look at taking the pressure out of the system by looking at the manholes upstream of the particular connections with the homes and allowing more venting before it got, and the pressure to relieve itself before it got to the interconnections with the homes. So with that, we used vented manholes with carbon inserts. Next. And the chemical addition was also made there as well. So conclusions were physical layouts can create a lot of problems. The answers are not always have to be cost prohibitive. Look for simple solutions first. And the moral of the story is observe, monitor, review, and kind of keep it simple as you can. And just to find your path to being a good neighbor.
Fantastic. Thank you, Dick. Sorry about all that delay. Yes, you covered great, and I think your presentation was very clear. I saw one question. I think we have about a minute. It says, any thoughts on whether it's better to use iron?
that was from the previous one.
Okay.
This presentation.
There would be a question, would it be better to do liquid or chemical treatment upstream of that slope? And then you would bind the odor. So when it does vaporize, you don't have to worry about the off-gassing?
Yeah, in both situations, there was chemical addition. Well, I should say in the first case, there was chemical addition upstream, but it was a 3 or 4 miles length of the force main, and it wasn't always effective. So we did tend to get stripping or action. Our recommendation for the second example was just to do exactly that, to add chemicals so that it minimized the amount of H2S or actually odors that would be stripped out.
Okay, very good.